Hi, this is the first in a series of 4 videos intended to teach you the Smart Account from Scratch series. I'm going to be going over my own implementation of how I would do this, but you're welcome to do it your own way, so long as you satisfy the goals along the way. So this series is intended to demystify smart accounts and ERC-4337 by having you get your hands dirty and building things from scratch. So that's what we're going to be doing here. You can use this guide to go along at your own pace or follow along with what I'm doing if you'd like to do it the same way that I am doing it here. So let's go ahead and create ourselves a new repository and we'll begin. So what I'm going to call my repository is Smart Accounts, and I'm going to go ahead and jump into that folder and go ahead and create this. So let's open this up in VS Code. There we go. All right, so now that we're inside of the Smart Accounts folder here, what I'm going to do is I'm going to create a new package.json. So you can see that's being created right here. I'm going to install Hardhat. And that should take just a moment to install there. Sweet. And we will do npx hardhat init to create a new Hardhat project. I'm going to go ahead and use JavaScript here because I don't want to get hung up on any TypeScript stuff. Although I typically use TypeScript here, it can be pretty useful. All right, great. So let's go ahead and jump in here now that we have all these contracts. So Hardhat has filled out some very basic stuff for us here. We have a lock contract, we have some scripts, we have a test. I'm not going to be using unit tests in this particular case because at the end of this series, what we want to do is we want to be deploying these smart contracts to a test net. So I am just not going to use unit tests, but if you want to use unit tests for this exercise, you're more than welcome to. I'm going to write scripts so that by the end of this, we can just deploy those scripts out into the test net and be able to test things out from there. So let's go ahead and do the first step, which is going to be deploying an entry point. So in order to deploy an entry point, what I'm going to need to do is I'm going to use a reference implementation of the entry point. This is a standard neutral contract that you will use. It's going to be the first thing that you interact with when you are creating a user operation that's going to be executed on chain. So we're going to see a lot of the entry point, a lot of the issues that may come up or errors that are going to be stemming from the entry point. So the better you can learn this smart contract, the more you could be effective within the ERC-4337 system. All right, so let's go ahead and pull up. I have over here in Chrome somewhere, I have this repository here. The Ethereum Foundation and several other contributors work on this repository here called Account Abstraction. And inside of this Account Abstraction repository, we have things like the entry point. So I'm going to go ahead and use this repository here for what we're doing. Specifically, we're going to be getting this entry point contract here. And what's really nice here is we can actually use this and install it with npm. So we can actually go look up npm and install these contracts into our Hardhat repository, and that way we could just reference them when we want to import them. So let me go ahead and just do this over here. I'm going to say npm I believe there's an @ symbol there. Oh, nope, it's account abstraction. Oops. We'll do this. And I have too many npmis. We'll do npmi account abstraction contracts, and I'm going to do this at 0.6.0. That's what we have it pinned on the guide as currently. That way, when you're doing this exercise, you're doing it at the same version as we're doing it in the future when there's new versions released, or you're welcome to also try this at a newer version when one is released. So let's go ahead and install 0.6.0. And so that's what that's going to give us is inside of here is a bunch of contracts that we're going to need. Specifically, we're going to need this entry point here. So what I'm going to do is I'm going to go ahead and try to deploy this entry point. So in order to do that, I'm just going to change this contract over to be called account.sol. And inside of account.sol, the only thing I'm going to do for now is just import our entry point. This way, when I go to compile, it's going to compile an artifact for us that we can use to go ahead and deploy this contract onto our local Hardhat chain. So let me go ahead and say account abstraction / contracts. Oh, look at that. It filled it out for me already. Account abstraction contracts / core entry point. That's what I want to import. So hopefully if I click here, it'll bring me over to the entry point contract. We're going to be taking a look at this entry point contract a lot through this video. So we'll get to know it a lot better. All right, great. So I already imported that. So the next thing I want to do is I want to deploy this entry point. So in order to do that, I'm going to create a script called deploy. Let's call it deploy EP. the entry point. I'm going to get rid of some of these comments here, although they are useful when you're starting out. And what we'll do is we'll deploy the entry point. Now, the entry point, I don't believe takes any arguments because it does not have its own constructor. Yes, there is no constructor. All right, so it's not going to take any entry points on deployment, or it's not going to take any arguments on deployment, so I can get rid of these two right here. And I'm going to go ahead and deploy this here, and we're just going to take a look at where we end up deploying this to. Now, I mentioned this in the guide, and I'll mention this here as well. What we want to do in these first few exercises is deploy this to our local blockchain to make things easier. But once we get up to the fourth step, we're going to be deploying this to a testnet. So for now, I'm just going to deploy this to our local blockchain, and we'll know whether we succeeded or not, whether we get an address for this entry point, right? And we can go look up and see if there's any code at that address. So let's go ahead and do that. So I'm going to create a new terminal here. So I have two terminals. One is just going to run my local hard hat node. So I'm going to say npx hard hat node. Now, if I want to deploy things to this local hard hat node, I do need to go and configure this inside of my hard hat config. So I'm just going to go ahead and set my default network to localhost. This localhost is going to be this one here. This chain is running on localhost 8545. And I just want to make it so that I don't have to pass in a network flag every time that I go to run a script. So this way, it's just always going to be deploying to this local host here. So hopefully now what we can do is we can go ahead and deploy this entry point to my local hard hat node, and we'll see whether that's working. So let me go ahead and say npx hard hat run script / deploy ep.js. And okay, so we ran into an error here, one that hopefully will be resolved by the time that you go ahead and try this out for yourself. It's saying that we are missing Open Zeppelin contracts, so we are going to have to install this. Now, depending on what version you're using for the account abstraction contracts, you may need a different Open Zeppelin version. So for example, when I come back over here, currently we're on version 0.6. That's the one we're using for this. That's why I installed it at 0.6.0. And if we look in here at the top level, we can see that the Open Zeppelin contracts are being used at version 4.2. You want to make sure that this matches up because otherwise it's not going to compile, right? If the contracts are different, if it's using Open Zeppelin contracts for a more recent version, it's using Open Zeppelin contracts at 5.0, you're going to run into an issue. So you may not have to do this if this has been resolved, but for now, this the account abstraction contracts folder does not come with this installed, so I'm just going to have to install Open Zeppelin at 4.2 there. So I'll go ahead and do that as well. And now, hopefully, when we go ahead and deploy this, we won't get that error again, but we do get a different error. And this error is telling me that the entry point is a very large contract. And in order to fix that, we are going to need to optimize it further by setting the compiler optimizer settings. So let's go ahead and do that. So I forget how to do this for hard hat. I put it in the guide how you can do it, but if you need to look this up, I just like to do hard hat compiler settings. And then we can go in here to compile your contracts. And in here, you can see that we could set these settings here. Specifically, we're going to set the Solidity settings. And I have this at 0.1819, so I'm going to keep that. And then I'm going to set the optimizer here. This is going to go ahead and shrink down our contract size here. So that's what I'm going to go ahead and set those settings to. I believe this settings is going to work for us enough to shrink it down to that target contract size. So let me go ahead and run this again. And hopefully now we have deployed our entry point. Okay, we can see evidence of that. If we look over here at our local hard hat node, we can see that the entry point has been deployed. If we want to prove it to ourselves further, maybe we can write a script called test that is just going to test that there is indeed code at that entry point. So let me just get the EP address here is going to be equal to this one that we just deployed. And we'll get let's just see what the code is at that address, right? So I can do HRE, I'm going to do a wait, HRE.ethers.getCode, provider, sorry, get code. And then we'll pass this EPA address, and then we'll get this code. And if there's code at that address, then we know that it's been deployed properly, right? So let's go ahead, and type in the code there. And let's just make sure that's working by saying run scripts test.js. And that looks like a bunch of code. So I think we're in good shape. It looks like the entry point has been deployed. So that's the first task in this guide. The next thing that we need to do is we need to start writing our account function code. So for the account, what we're going to do here is we're also going to make use of something from this account abstraction repository here where we can go in to our node modules, account abstraction. We're going to need the interface for the account here. So you can see there's an interface for the account. It has only one method in it called validate UserOp. So this is the only method that we actually have to implement for a valid account. Everything else is really up to you. If you want to create a method called execute, if you want to create a method called hello world, whatever you want to create, you can create. This is your account. You do just have to put in this validate UserOp, which has a very specific signature here for how you should tell the entry point whether or not this is a valid UserOp that could be run against your account. This is the opportunity, this method right here, which we'll see in step 3, is the opportunity for us to validate that the signature is indeed somebody who is allowed to execute an user operation against our account. So let's go ahead and pull this function over into our account. I'm going to create a contract account that is an I account. Let me close out of these two to make this a little bit easier to see here. And I'm going to pull over that function and I'm going to create a body for this. Now for this first step, what I'm going to do is I'm just going to return 0. This is going to be a special value here that is just going to allow us to allow any user op to go through on our account. We're going to be talking about validation a little bit later. It deserves its own step. But for now, I just want to say every user operation is valid against my smart account. Allow anybody to interact with this on the account's behalf. So let's go ahead and get rid of some of these variable names. That way we don't get some of these compiler warnings. It's also going to tell me that this can now be restricted to pure because we're not doing anything here. We're just returning 0, right? So we're always just going to be returning 0 for this account. I do need to go get this interface. The interface is going to be at in account abstraction contracts interfaces /iaccount.sol. So now we should have that I account that's linking to the file that we just saw a moment ago. Although, oh, that's interesting. For some reason, it's coming up with that one. Okay, there's the I account though. And you can see the validate user up here. So in this case, we're just going to return 0 for the validation data. We can do a lot more with the validation data, but like I said, 0 for now. Because we want to keep things really, really simple. And we're not even worried about any of the arguments here, which we could use later on to validate that the user operation is indeed something that we want to execute against our account. Okay, awesome. So we have this account. It's an I account. We're validating every user op saying that, yes, indeed, these are valid user operations. Something that I want to do with this account is I want to do some sort of state change. That way we know that the user operation is actually executing something, that it's actually doing something. This is what we're going to use to test on our local blockchain whether or not we're actually able to run a user operation, which is the goal of this step. So that's what I'm going to do is I'm going to create some state. The state that I'm going to create is going to be, let's call it count. So count is just going to keep track of a number. We're going to just increase it every time that we interact with the account, maybe through a function. You could call this whatever you like. So I'm just going to call it execute, which is very generic. And all we're going to do is say count plus plus. So when we want to execute something against our account, we'll go ahead and say count plus plus. Something we might want to do now to set ourselves up for later. It does add a little bit of complexity to this step, but I think it's worth it to introduce this now, is maybe to have a constructor that takes in an owner so that we can check the owner later. Right? And the beautiful thing about account abstraction is you get to define whatever logic you'd like for whoever is the owner and what kind of signatures they can sign on this account here, right? So this is our logic, but you could define whatever kind of logic you need to in order to make your account what you need it to be for your users. So I'm going to go ahead and say owner is equal to owner. I am going to create a state variable called owner. That way we can have something here to track it. And awesome. Okay, so cool. So we have everything I think we really need in the account for now. Like I said, you could add more to this if you'd like to. If you're testing out something in a smart account, feel free to. You have full programmability inside of this smart account here. So that is everything we need for the moment. What I'm going to do beyond that, the next thing that we have to do is we have to create an account factory. Now for the account factory, what I want to do is I want to take a look at the entry point to understand how the entry point is going to interact with the account when it's first creating it, right? Like what do we do when the entry point knows that there's no account out there for this user? How does it create that smart account? Let's go to the entry point to find out. So there's a method somewhere. It's something like create, there we go, create sender if needed. So this method is going to get called every time we go to run a user operation. So we can see where it's getting called here inside of this validate account prepayment. This is going to happen for every user operation. So create sender if needed is always going to be called for each operation. You can see this op info here, which is a representation of the user op. It's going to have a lot of the same fields that the user op will have when we pass that in. So let's go ahead and in this create sender if needed, what we're going to notice is there's something called init code here. This init code is something that we're going to pass in with the user operation. It's saying that if it's not 0, then we're going to go ahead and initialize a smart contract. So that's something to keep in the top of your head here, is that if you are passing in init code, you're telling the entry point to run this code to essentially create a smart account, right? To go ahead and initialize the smart account. So if init code is not equal to 0, what we're going to do is we're going to get this sender. This sender is going to be the smart account address, and what we're going to do is we're going to go ahead and create that sender. So this sender right here, what it's going to do is it's going to test that the sender that you passed into the user op is the same as the sender that it gets back from this create sender method. Now something for us to go take a look at is the sender creator right here is actually a contract that is created by the entry point that is meant to just be a neutral smart contract for deploying your smart account here. And what it's going to do is it's going to take this init code and it's going to use that to initialize your smart contract. So let's go ahead and take a look at that code to see what exactly it's doing with the init code. I'm going to go into the sender creator here. You can see it's a new smart contract initialized in the entry point. So we need to go ahead and pull up the sender creator.sol to go ahead and see what it's doing. Okay. So I know this can get a little bit complex here if you don't know your Solidity really down pat, especially your assembly here, but I'm going to try to explain it on a very high level. So in the sender creator here, what it's doing is it's taking in the init code. And I mentioned a moment ago that the init code is one of these fields in the user operation. What it's going to do with the init code is it's going to take the first 20 bytes of the init code, and that is going to be the address of the factory. So that's something that we have to keep in mind, is the first 20 bytes of the init code when we go to put it in the user operation is going to be this factory address. So we need to deploy a factory, and then we need to put it inside of this init code. The rest of the init code is going to be this init call data. So it's going to be what we're sending over to the account factory. So if we're targeting a method, we're trying to pass some method arguments, this is where we would put that in, right? That call data to initialize the smart account. And this right here, this assembly, you don't have to worry about it too much. I'm going to just tell you what, on a high level, what it's doing. It's just sending to the factory address this init call data here, right? Just like I said, we're targeting some sort of a method on the factory. We get to define what that method is as the developer of the smart account and the smart account factory. So we can name it whatever we want again here. So we have that full flexibility. And then the other thing it is going to require is that you do return a sender address because it's going to check that up one method like we saw just a moment ago. So let's go ahead and create this method that we're going to have be called on the factory. So we need to create this contract account factory. And we basically have full reign to do whatever we want with the account factory. So if you want to create a function called, let's call it create account, which is going to go ahead and create our account, you could have many different factory methods on here, right? With all different signatures, different arguments that are being passed in. In this case, all I want to do is I want to take an address owner. And the address owner is something that I'm going to pass over to the account in the constructor here when I create this account. So this create account function is going to be external. And what we're going to do is we're going to go ahead and create a new account by saying account ACC is equal to new account, passing in the owner here. Cool. So this will deploy a new smart account when we call this function from the entry point. And then what we're going to do here is we're going to return this account as an address. And I do need to change my signature here to accommodate that and say returns address. And boom, that's our account factory. That's all we need to do. Like I said, this is totally up to you. We're going to be creating this call data from our side in the script when we put it in the user operation. So as long as you encode the correct call data to target this method, you can name it whatever you want, passing in whatever kind of arguments that you want to pass in. Great. So this is all the Solidity that we need to do on this step, and hopefully this will all work out well. So let's go ahead and jump into the next part, which is we are going to, well, the next thing that we really need to do here is we want to deploy the account factory, right? Because we also want to have that in a static place so that we can use that address for the user operation when we're creating that init code. Because if you remember, the first 20 bytes of that init code is going to be our account factory, right? So let's go ahead and also deploy the account factory here. So I'm also just going to name it AF there. And I'm just going to take this over here and I'm going to call this account factory, and we'll do AF. All right. So our account factory can be deployed as well. Let's go ahead and do that. So let me clear this out. I'm going to say npx hardhat run script/deploy af.js. Let's send that out there. Great. So now we have the account factory deployed. We have the entry point deployed. We're actually all ready to start to execute our user operation. So let's go ahead and do that. We're going to do a execute script. And in here, I'm just going to copy this bare bones and create this main function. I do think I'm going to need this entry point artifact, so I'm just going to keep that as is. So let's go ahead and start doing this. Okay, so what I need to do is I need to create a UserOp. The UserOp is going to have a bunch of fields, and I, for the life of me, will not be ever able to remember all of the fields. So what I'm going to go do is I'm going to go look up the struct inside of the smart contract. So let's go do that. So if we go to the account here, and if we go to iAccount, now it's actually going to iAccount. That's great. Inside here, it's actually importing from this user operation.sol, where it's going to define the user operation struct. Now I'm just going to copy this user operation struct over. So let me just close out of some of those and pull this on over to our execute function. So here we're going to go ahead and paste all these different fields, and don't mind me for a second while I get rid of some of these type keywords. Fortunately for us, we're really not going to need to fill in all of these variables with something important right now. Like for example, like our signature, we're not validating a signature in the account. Like I said, I'm just returning 0 here, right, inside of the validate user operation. Because we're just returning 0, it doesn't matter what our signature is because we're just going to say every user op is valid. So we don't have to worry about that for now. For the paymaster, we're actually not using a paymaster in this step, but we will in the next step. So we're also not going to worry about that for now. These values here for the gas and for the gas limits, I am just going to put some basic values in here that I know will be enough for these, just for some dummy values. But later on, we'll fill in some actual good values by getting these estimates from Alchemy's bundler API. So for now, I'm just going to fill in some basic estimates that I know will be valid. For our max fee per gas, we're going to do this in GUI. So let's do hre.ethers.parse units. Let's do 10 GUI. And for the max priority fee per gas, let's do 5 GUI. All right, and I need my commas. All right, so that's it for the dummy values. Now we're on to the trickier part, which is all of these values here. So let me just make sure it's not mad at me for semicolons and syntax, and then we'll get on to these harder values like the sender, the nonce, the init code, and the call data. All right, cool. So for the sender, something that is going to come up maybe a little bit later is right now I'm using create. There's actually another opcode that we could be using for creating our smart contract, which is called create2. So where I'm using create is right over here in the account factory. This is the standard way to create a smart contract using the create opcode. You could also be using create too. Now, the difference between these opcodes is the way that the address is determined for the smart contract that gets deployed. A really interesting thing about how this user operation works in the system is we need to actually come up with the sender address before the sender is created. So we're going to have to calculate that here. For create, the address ends up being the catch-rack hash of the sender plus the nonce of that contract. And then for create 2, it's going to be some placeholder plus, I believe, the sender, the bytecode, and some salt. I forget the ordering of this exactly, so these two may be flipped around or something like that, but those are the components, right? So for create, it's sender plus nonce. For create 2, you can actually do something more deterministic here because you don't have to worry about the nonce. You don't have to know about how many times the smart contract has been deployed from that contract. Rather, you could just put in the bytecode and whatever salt you want to put in to be able to create that smart contract. We'll see a little bit later why create 2 might be more preferable here, but I wanted to keep things pretty simple, so I just used create, and we'll see what we need to do for that. So for the sender for the nonce, we do need to get this sender address here in this case. The sender address is going to be the account factory, right? Because in this case, we're talking about who is deploying the smart contract that is going to tell us what this sender address here is. Now, this is a little confusing. This sender here, I should really call this the deployer because I'm trying to get the address of the smart account. This sender right here is going to be the smart account address. Whereas this one right here, we're trying to figure out what the address of the sender is going to be by taking the hash of the deployer, which is the account factory, and its nonce. So the account factory nonce is something that we're going to need here. So let's just call it factory nonce. Something to know about contracts, their nonces, is that they start at 1. I believe this is ever since the Spurious Dragon upgrade. They start at 1, so before that upgrade, contracts started at 0. But for now, they start at 1, so that's important to note. So the first nonce is going to be 1. If you want to deploy another smart contract, you're just going to have to manually upgrade this nonce so that we get a different address here. So I'm going to put my factory nonce to be 1 to begin with. And then the other thing that I'm going to do is I'm going to get our factory address, which we deployed, right? This is going to give me everything I need to do in order to be able to get the address of the sender, the smart contract address, even though we haven't deployed it yet, right? So our account factory is going to be deployed to this address here. And so we can plug this in. While I'm at it, I might want to get our entry point address as well, which I know we deployed. Here we go. Right here. All right, great. These are the things that I need. I don't need the entry point for right now, but we will need it shortly. Let's go ahead and clear this out. And okay, so to get the sender address, what we're going to need to do is we're going to need to calculate it. It's going to be, again, like I said, the factory address and the factory nonce. So there are handy methods on both ethers and VM that we can use here, which we can say HRE ethers dot get contract address. Is that right? No, get create address. There we go. Okay. So there's get create to address and get create address. Get create address, what we need to pass in here is just the two things, like I mentioned, who this is coming from, which is going to be the factory address. That's the deployer. And then the nonce, which is going to be something that we're plugging in here manually. If you want to deploy another smart account, you can just increment this nonce each time. But as long as we're referring to the same smart account, which we're going to want to execute multiple user operations against this smart account, we're going to want to keep this nonce at 1, so we target that same smart account every time. So there is our sender address. So we are done with one of these fields. The next field that we want to go ahead and plug in is going to be our nonce. Now the nonce is not because this is a user operation, and the user operation really exists from the entry point on, this nonce is referring to a nonce system that is managed by the entry point. So we can actually find that in here in the entry point. You can see that the entry point is a couple things. It implements the EntryPoint interface, and it implements a reentrancy guard, which is a nice feature to have in here for safety. But the other two things that we're going to be taking a look at is stake manager and the nonce manager. Stake manager will come into later, but the nonce manager is the thing that I was talking about just now, which is we're going to need to manage a nonce within the entry point itself. So I come in here to the nonce manager, and you can see that there's this mapping that is going to keep track of nonces towards our different smart accounts. It's also going to give you this opportunity to be able to supply a key, so that if you want to have multiple nonces for each smart account, you could do that, right? So like if you had a smart account where you want to send two different transactions and they had nothing to do with each other, so you didn't want to have to execute them in sequence, you could actually deploy them with different nonce keys. That way one does not depend on the other, right? Whereas in traditional nonce, when you send a transaction, let's say, from an EOA, and you send a first transaction, you need to send it with a nonce 0, and then the second transaction with a nonce 1. The second transaction can't actually get executed until the nonce of the account has been incremented to 1, right? So they are kind of sequentially linked. This key gets, potentially removes that need for sequential ordering in the cases where you don't need that sequential ordering, right? So it gives us a bit of flexibility here. For our case, we're just going to use a nonce key of 0, so we don't have to add anything in additionally here. So what I'm going to go ahead and do here is I'm just going to say await. I'm going to get the nonce from the nonce manager. So I'm going to go ahead and get the nonce for our smart contract. We have this method called get nonce, and it's going to take in the smart contract or the smart account, and it's going to take in the key here. Like I said, I'm going to use key 0. So let's go ahead and say EntryPoint dot get nonce. I'm going to pass in our sender, and then I'm going to pass in 0. Now, one thing I did not do is this deploy contract. Instead of deploying contract, we already have our entry point deployed, and I want to reuse this execute script to be able to run user operations against this smart account later. So I don't want to have to deploy everything inside of the script every time. So what I'm going to do is, instead of saying deploy contract, I'm going to say get contract at. There's already an existing entry point at this entry point address that we deployed just a moment ago. So I'm going to go ahead and get that entry point here, and I'm going to rename this to entry point. Great. So now we're going to go ahead and get that nonce for that sender. So every time I run a user operation, it should go ahead and get that nonce dynamically, right? So I don't need to go worry about what the nonce is for that particular user operation. The next thing that we're going to do with the init code, now this is where it gets a little complicated, right? With the init code, we remember that the way that it worked is inside of the entry point, we had this sender creator, right? And the sender creator takes some init code, which is the same init code that we're looking at on the front end here. The init code is going to take the first 20 bytes is going to be the factory address. And the rest of the init call data is going to be exactly the rest of the init code is going to be the call data that we send to the factory. So what do we want that call data to be? Well, we need to go look back at our account to see what that is. And in our account factory, we have this function called create account. So what we want our call data to be is we want it to be this method create account plus this argument owner. So we're going to have to encode that call data ourselves. So we'll have to, maybe we could just pull in this contract account factory, the artifact, so that we can encode the call data via its interface. So let's go ahead and do that, right? So let's get the init code. So the init code is going to be two things, right? The first 20 bytes are going to be the factory address. And then it's also going to need to encode that function data from the interface of the account factory. So let's get the account factory here. Let's get the artifact is going to be await hre.ethers.get contract. Get contract factory. And we will go ahead and get the account factory here. Great. Okay, so now what we're going to do is we're going to go ahead and say account factory dot interface encode function data. That's the one I'm looking for. Okay, cool. So we have this contract factory, not to be confused with the idea of a account factory, right? Contract factory is an Ether specific term, an Ether specific tool here that we can use to deploy new contracts, whereas the account factory is an on-chain smart contract that can deploy smart contracts. Kind of an interesting double use of the factory term there, but nonetheless, we have a contract factory of our account factory, which we're going to use to encode this function data, the call data, to target that method, which is called create account. So what this encode function data is going to allow us to do is target a method by its name. So we could say create account here. It'll go look that up inside of the ABI that it has thanks to this lookup, this get contract factory lookup. So it's going to go ahead and grab the ABI, find the method called create account, and it's going to allow us to encode this call data here. So we could say encode function data, pass in create account, and then for the arguments, we're just going to pass in one, who the owner of the smart account should be. Now, a question that comes in here is who should be the owner of the smart account. We can go ahead and just use the first signer from our signers, which is going to be this signer up here, right? That first account that's created in our local host blockchain here. So let's go ahead and get that first signer. Signer 0. We'll get it out of the array of await HRE ethers that gets signers. And this will return all the signers. I'm just going to get that first one. And then we want the address of that signer here. So I'm going to go ahead and say address 0 is equal to await signer 0.get address. And we'll just go ahead and plug this in here. I put these up at the top in case we need them somewhere else, but maybe it makes more sense to put them down here. Just to keep them close to the code that's actually using them, right? Great. So this is going to be the factory address, plus we're going to encode the function data for the create account. So now we have the first 20 bytes are the address of what we're targeting, followed by the call data that actually targets the method to create the smart account. So this init code can now have a comma there. Whoop. And this needs a comma as well. Great. Cool. So double checking that, we come back over here to our sender creator, and the first 20 bytes is going to be the factory, and then the rest is going to be the init call data that's going to be sent over to our smart account factory, right? And then we're returning the address so it can look up and double check that the address is the same as the one we sent through to the user operation. Awesome. Okay, so we're getting pretty far along here. The last thing we need to do is call data. Now, I was talking about overloaded terms with the factory here just a moment ago. Call data is definitely one that gets used a lot when you're this low level inside of account abstraction, ERC-4337 style. This call data is the call data that belongs to the UserOp. So this call data is not the call data of the transaction necessarily, right? This is the call data of what's happening starting from the smart account on, right? So what do we want to do with the smart account? Well, in this case, what I want to do is I want to execute, right? I just want to be able to run count ++ so I can make a state change, but this could be anything, right? This execute function here, we could be interacting with Uniswap contracts from here, right? So depending on what we wanted to do, we could change this function signature around. We could call out to other smart contracts in the ecosystem. We could do whatever we wanted to here, right? All I'm going to do though is target this execute function. So I need the call data to be able to do that. So similar to what we were doing just a moment ago, I'm going to need the contract factory for the account, right? And this is going to give me the ability to be able to use that interface on Ethers to be able to encode the call data that we need for the account there. So I'm going to go ahead and say account.interface and then encode function data. And then the function we're trying to call is execute. And I'm not passing any arguments here, so I'm just going to leave that blank. And that should about do it for our UserOp. Cool. So once we have a UserOp, later on in other stages, you pass UserOps to something called a bundler, which is going to be something that takes UserOps. It's another off-chain component. You can think of it kind of like a node, but a special type of node that takes a user operation. In this case, I want to keep things simple. I'm just going to hand this UserOp directly to the entry point that we deployed in our local blockchain because I'm not running a bundler in my local blockchain at the moment. So let's go ahead and do that. I'm going to say entry point. Now, entry point has a method that takes user operations, and we need to go look that up. It's called handle ops. So let's go find it. Okay, so you can see that this handle ops method takes a array of user operations, and then it also takes an address, a beneficiary for who should receive the fees. Typically, this might be the address of the bundler that is sending your operations over to the entry point here. But in our case, we don't have the bundler. I'm just going to go ahead and use the address 0 that we got earlier. So I'm going to say handle ops. I'm going to pass in the UserOp, and then I'm going to pass in the address 0 as the beneficiary. And that should about do it. So let's get the transaction back here, and then I'm going to get the receipt is going to be await transaction.wait for when it gets included, and then I'm going to console.log the receipt, and we'll see whether or not it looks like this transaction was successful. I want to test this a little bit more to see if that count goes up every time, right? That's going to be a real like satisfying moment of like, did we do this or not? But for now, let's just go back and just see if we can execute this user operation here. So I'm going to go ahead and say npx hardhat run scripts/execute.js. And let's see what we get back here. Okay, it did not like something. It says something was an invalid bytes. Oop, I forgot one thing, which you may have seen. I totally forgot. But this factory address right here is going to be 0x followed by the address. This account factory encoded data right here is also going to have 0x at the beginning because it's a hex encoded string. So it has that 0x to indicate that it's a hex value. Now, the issue that it's telling me here is that this right here is not a hex value because it has 0x right here, and then it has the address, and then there's another 0x right here, right? X is not a valid hexadecimal value. It indicates that we're using hexadecimal. I want to slice that off, so I'm going to take off the first two values here, and now we actually have valid bytecode that we can send along. So let's go ahead and execute that. Cool. Okay, so not the same error, so that's always a good thing, right? What it's telling me now is AA21 didn't pay the pre-fund. This is really important that you see something like this because these AA errors are coming from the entry point. So when you get an AA error, which you might often get, even when you're dealing with some abstraction libraries, things that are going to help extract some of the difficulty that we're doing here, you're going to see these types of errors. So this particular error, we can go look up. You might be able to tell from the error what's actually happening here, but let's go look it up in the entry point to see exactly what's going on. So it's saying AA21 didn't pre-fund when the required pre-fund, which is something that is calculated via some gas estimations of how much the operation is going to require. It is saying the required pre-fund is greater than the deposit. If that's true, then throw the error that we saw. So there needs to be some sort of a deposit here. The deposit is going to be a certain amount of money that maybe a paymaster or a smart account puts on the entry point to say, I am willing to pay for the gas for this user operation. When we have a paymaster later, it can sponsor the user operation on behalf of the account. But for now, we don't have a paymaster. So we do need to deposit some funds from the smart account itself. So in order to do this, what I'm going to do is I'm going to go look up this deposits mapping and see where it's coming from. So we can go find this here. It's inside of the stake manager. Now remember, the stake manager is one of the contracts that the entry point inherits from. So this is part of the entry point contract. It's just put inside of this abstract contract container, which helps us, keep things neat, right? This stake manager is going to be where you find all of the pertinent code to managing deposits and stakes. So for now, for deposit, for this particular case, we're just going to worry about the deposit because that's what it's looking up, is to see whether we have deposited some funds that will pay for gas. So what we need to do is we need to send to this deposit to method on behalf of the smart account some ether that it can then store against the entry point to pay for gas. So that's what we need to do here. We need to pre-fund. So let's go back to our execute function. And here, before we send the user operation, we're going to go ahead and pre-fund. So I need to do that EntryPoint dot deposit to method, and this is going to take an address. We're going to be depositing on behalf of our smart account, and let's just do something like enough that we know we could cover a bunch of user operations, right? So we have I think 10,000 ether in all of our different accounts here. If we look back up, right, it's like something very high, yeah, 10,000. So let's just put like the value at like I don't know, 100. We'll do HRE.ethers. Parse ether 100. That should be enough for all of our user operations so that we don't have to worry about pre-funding this again. So I'm just going to do this once, this first time, and then hopefully we won't run into this error here. The AA21 didn't pre-fund. Let's go ahead and run this again. Okay, great. That looks like a valid user operation went through. It was included inside of a block number. There's a block hash. If we come over here, it looks like the handle ops contract call was successful. Awesome. So we did it, right? Let's just, before we conclude this video, let's just double check that that state change went through, right? That's what we're really trying to do, is we're trying to get that count to go up on our smart account. So let's come back over here to our test, and instead of just testing that the entry point has some code here, let's go ahead and get our smart account address. So I don't actually have the smart account address here. At least I can't see where it is, so I might want to log that out. So let's go ahead and log out the account. Keep in mind here, oh, sorry, not the account, the address, the sender address. So keep in mind here, I am going to be running the user operation again. This second time through, one thing I don't want to do is pre-fund again. I don't need to do that. Maybe we could like detect whether or not there's a balance there on the deposit by using the, on the entry point in the stake manager, there's a balance of method. So you could like look up to see whether you've already deposited. If you haven't, then you could pre-deposit to make this script a little bit more reusable. I'm just going to go ahead and comment that out for now. And then the init code, remember when we were looking at the entry point in that sender creator? In here, oh, sorry, actually it wasn't in this part, it was in the create if not needed. You can see that it's running this code if the init code.length is greater than 0, right? It's not actually checking to see if that smart account has been deployed. It's just checking to see if the init code.length is not equal to 0. So in future runs of this user operation, if we want to run this user operation again, we do want to just not put in any init code here, right? That's something that we'll want to do. So that way we don't reinitialize or try to reinitialize on a smart account that's already initialized, because it's going to come up with the same smart account address because we're using the same factory nonce here until we decide to go ahead and try to send it from a new sender in a future run. Okay, great. So let's go ahead and log out that sender, and we're executing another user operation. So the count should have gone up twice now. Here's our smart account right here. I'm going to bring this over into our test, and I'm going to call this the account address. And what I'm going to do is I'm going to go ahead and say account is equal to await hre.ethers.get contract factory. No, get contract at. We're going to call this account and account address. And let's just see what that count is, right? Let's go ahead and look up what the count is. Account.count. We're going to have to await this and then log out the count here. So hopefully at this point it should be like 2, right? Because we ran this twice. Let's go ahead and run scripts test. And there's our 2. Cool. 2n, because it's coming back as a big number. For whatever reason. But if we wanted to, we could keep running user operations by running execute, because this is just going to keep running that execute function. And I did it 3 more times, so our count should now be 5. Okay, great. So we executed the user operation. That's what we wanted to do. Right now, we're not doing any sort of validation, right? So something to keep in mind is that if we were to deploy this smart account, to a chain that other people could access right now, anyone could run a user operation against this account. Even though we created this user address, we didn't actually use it. We do want to use that inside of the validate UserOp in a future stage. We also might want to make it so that paymaster, somebody else, some third party, is able to pay gas on behalf of this account. And we'll see that in the next step, how we're going to do that. Great. So hopefully you enjoyed this video. I'll see you in the next video when we go over paymasters.